This video summarizes a new Python code to filter through the NCEI Storm Events database. We all know and love that database that contains storm reports of events like tornadoes, hail, and severe wind. And this tool allows you to build databases of different hazard combinations from those reports. And so what does the filter itself do? It can filter by geography. You can specify a region based on a group of states, such as the Southern Plains, or a sub-region based on a group of counties, such as the Oklahoma City metro area. You can specify a single state or a single county within a state. You can also specify a state plus all adjoining states. And then you can also identify based on the CONUS as a whole. So there's a robust geography filter in the program. There's also a robust time filter in the program. You can specify a range of years or a single year. You can specify based on the time of year, based on the month, based on the day, and based on the time of day. There's also a function in the time sorter where you can specify events that are reported within a certain hour window, for example, a 3-hour window, relative to a 12 UTC or 0 UTC sounding observation time. The main core of the program is sorting by hazards. You can specify a primary hazard type, and then you can also specify a conditional hazard type. So for example, say your primary hazard type is a tornado, but you want to identify tornadoes where there wasn't really large hail in proximity to that tornado, and so you can specify a conditional hazard of hail less than, say, 1.5 or 2 inches within 250 kilometers of that tornado event. And so you can tie the maximum hail in proximity to that tornado to the tornado itself. So the program functions basically through a series of include and exclude rules that allow you to find different types of events of varying severity and varying types of severe reports. We could also exclude or include events that occur within spatial proximity to an upper air site that it has data available from the Wyoming database. So the code actually scrapes the Wyoming upper air website to see if the data are available without actually downloading the data. And then you can also filter by a min or max distance relative to the nearest radar or sounding site. And so you can make sure that you're looking at approximate sounding to the report, or you can specify a certain range from the radar if you're looking for a good viewing angle to the radar data and you want to have that storm be not too close or not too far from the radar. There's a keyword search. You can search separately the event narrative, the episode narrative, or both, and or logic is included with the string of keywords. And then in the end, the filter produces a CSV file that contains the full storm report event row from the raw NCEI data. And so here is the NOAA Storm Events database website. And we all probably know and love this. We can specify a state, or we can search the narrative from this main page. But to run the program, you're going to need to download the bulk data for at least one specific year. And so you're going to want to click on this link here. And again, the URL for the Storm Events database is down here at the bottom of the slide. So here's the bulk data download link in the upper left-hand corner. You're going to click this link here in the upper left-hand corner of the web page. This brings up a new dialog where you can access by FTP or HTTP the bulk data files from January 1950. As of this, it's through July 2025. And then when you go to, for example, the HTTP page, you have a website listing the links. You just click and download as you normally would to download these gzipped links. And then you're going to have to put them in your StormData folder in your directory here for your storm event filter. So we have the Python program here is the filter storm events Python code here. And then we have our output file. We have a reference folder that has some lists of state names and county names and that kind of thing. And then we have the StormData folder that is going to contain all of your storm data. And once you download these gzipped files, you need to extract that data using by right-clicking the file itself here and using the Extract All button to extract the data into a raw CSV. Okay, so here's your directory structure, which we just saw. You have a folder, which I here named Storm Events Filter. You have your filter stormevents.py file. In the reference folder, we have several CSV files that list the adjoining states for each state, the subregions, the counties, the radar locations, and the sounding locations. So these are the reference files that the program uses. And then we have a yearly storm data folder. So this is the structure here. And then we have the output file. Okay, so this is where your new CSV files that contain the filtered data sets are going to be placed. And you can specify subdirectories in this output folder here. Inside the Python code itself is where you specify your storm data path. And so if our folder here is called the Storm Events Filter, our storm data path here is just in our documents folder. We've got that storm events filter folder, and then we have our storm data folder right over here where we have the storm data. And then we're looking at the reference folder and our reference files for the geography here. If you go a little bit further down in the code, we've got the list of regions. You can alter this list very easily just by changing the state abbreviations here. I just have a simple set base of geographic regions across the country. On the right-hand side here, this is a look at the subregions.py. Sorry, this should be subregions.txt. Subregions.txt file. And so you have a name for the subregion. I have here OKC Metro and HRV for the Hudson River Valley, which is the focus of my research. We have the state and the county here. And so the different names are associated with the different subregions, and we just specify the counties we want to include in that subregion. Kind of a handy little thing to look for more localized storm events. To run the code, you do need to install a few Python packages. So I usually run my code in Spider IDE, and I use Anaconda to install the package as a package manager to install all of these packages. But you do have to have some of these packages for the code as constructed to run. If you're running in Spider, some of these packages do come as part of Spider, but not all of them do. Okay, so once you have the program installed and all set up, let's take a look at how it runs. Everything is by prompt. And so I have my local installation here, slightly different folder configuration than what I showed in the earlier part of the video. But once you have your storm data path specified in the top of the folder there where we just saw, this should be just an enter. You click enter by default, and it should locate your storm data path. And then you're going to select your storm year. So let's say we're looking at 2024. We go to an end year of 2024. We're just going to search 1 year here. And then you can specify the output directory and a subdirectory inside the output directory. I could do test here. And then, so it'll tell you where your output is going to be saved. You also have the option here to save a run configuration file with all user-defined parameters to this output directory. So if you want to keep track of what you specified when you were sorting through the data as far as your primary hazard, your conditional hazard, your thresholds for your ranges of your values, that kind of thing, you can save all of those parameters in a unique file in this output directory so that you can revisit this configuration at a later time to remember how you built this data set. So it's always a good idea to say yes and save that. So that now it loads the data, it reads the data. So now our geographic selection, we want to decide whether we want to filter by region, by subregion, by state, or by all. And so let's filter by state here. So I'm in Georgia, so we'll just say Georgia. So include adjoining states. This is asking, would you like to also include the surrounding states as part of your filter? So if you wanted to cast a wider net around your state, you could do that. I'm going to say no here. Would you like to specify counties within Georgia? I'm going to say no here, but you could specify individual counties. Just be careful if you do that you type them correctly when you enter them. Would you like to add another geographic level? So if I wanted to add a second state, I could say yes, and I could add another state of Florida. Okay, and again, I'm going to say no to the adjoining states here, but we could cast a wider net. Would I like to specify additional counties in Florida? I didn't do that for Georgia, so no, I'm not going to do that here. But you can see geographically there is a wide range. You could also specify, if I wanted to, I could specify a subregion, but I don't have any set up for Georgia or Florida, so let's say no for another geographic level. Okay, so that specs your geographical conditions. It'll search in any and all states, regions, subregions, or whatever that you specify in that geographic selection section. Now we're going to specify the time window of our report, so we know we're looking at 2024. So let's look at the entire year. So I'm just going to leave this blank for any. So my start month could be any month, and my end month could be any month. My start day, let's just look for the first 5 days of any month, right? So my start day is 1, my end day is 5. This will actually search the year 2024 every month from day 1 through 5, which is kind of an odd way to search. And would you like to identify cases near a sounding time? So basically, this is your temporal filter. Are you going to wanting to do it based on a specific sounding time, or you want to look at a specific range of hours? So I'm going to say that I do not want to specify based on a sounding time here. So now we go into specifying a start time. So maybe I want to go from 1200 to 2359. Okay. And so now I have my time window specified. Now we want to look at a hazard selection. So I'm going to look for, we kind of have an odd time specification with days 1 through 5, so we're going to keep this a little bit broad. We're going to look for hail. I'll show you how the magnitude filter works. We're going to apply a magnitude filter, yes, of a minimum magnitude of 1 inch, and we'll enter a maximum. We'll just say, 5, just include all hail that was likely in our Florida, Georgia region over this time period. Okay. Now, which events do we want to keep? So on these days, do we want to list all events contained within that window? We can also list the first primary event of the day. Again, this is from 8 local time to 8 local time the next day. Or we can identify the first primary event of the maximum magnitude that day. So if the maximum hail magnitude was 1.75 inches, our output file would, under the first max configuration, would contain only the first 1.75 inch report of that day. I'm just going to say all here because I don't really know what we're going to find. So we can apply a conditional hazard rule. So I'm going to say yes here. The conditional hazard, so we know that there's already been hail for the events that we're keeping in our output file. But let's say we also want to have wind occurring during that same day. Okay, so we could exclude days with wind, or we could exclude days with wind. Let's include days with wind. And then do we want to include or exclude the reports themselves? In other words, do we just want, here's a hail report that had a wind associated with it, or do we also want to see the wind report in the database as well? So I'm going to exclude the reports. We're going to winnow the data set down based on the inclusion of wind along with the hail, but we're not going to see the reports of the wind in the actual output file. Okay, I just want to know that that hail event had some wind associated with it. So are we going to apply a magnitude filter for the wind? Let's just say no. Okay, and then what is the spatial proximity of these wind events? So should they be within the same county as the primary event? Should they be within a certain kilometer distance of that event? Or is there no spatial restriction as long as they fall within our overall area of Florida and Georgia? Okay, so I'm going to specify, instead of typing the word number, I'm going to specify that they must have occurred within 100 kilometers. Okay, so you don't type the word number, you type the value in kilometers. And then we have a temporal proximity window for the wind events. So we can specify, in minutes or hours. So let's say 3 hours. Okay, 3 hours, 3H. And then we can search our keyword in the narratives. So let's do a search, and we'll just keep it simple. We'll search for hail. Okay. And since we only have one word, the logic doesn't really matter. And so it tells us what we've applied for this conditional hazard rule, and do we want to confirm it? We'll say yes. And then let's not add another conditional hazard rule, but you can see you can add as many conditional rules as you want to that primary hazard. Now, do we want to search for keywords in the primary narrative? Yes, let's search for both the event and episode narrative, and let's search for hail. And we'll use an AND logic. Okay, so we'll confirm this hazard setup for our primary hazard. We can add a second primary hazard. I'm not going to do that now, but we could also, say flash floods or something else. Now, do we want to exclude events without a Wyoming sounding? So I'll say no here, but we could specify a distance threshold to the Peachtree City sounding site in Georgia. We could specify a distance threshold to the Tallahassee sounding site in Florida, for example, for this data set. We can also specify a radar range, as I had mentioned before. We're not going to do that here. And we can also specify a sounding range. And I'm going to ignore that. And so we turned out to find 20 events from our filter. And those have been saved to this folder, and the file name is fairly long, but it contains the fact that we had the year 2024, days 1 through 5, times 1200 to 2359. Primary hazard is hail. Magnitude 1 to 5. Secondary hazard is wind. Narrative. I'm not sure what the NB here is, but the file name, does kind of let you know how you filtered this data set. Okay, and so that's the filter, and that's how it works. I hope you find it to be a helpful tool. And if you have questions, please find the GitHub page and email me at my email address on the GitHub page. Thank you, and I hope you enjoy the tool.